adjust for number of tests?
Doesn't adjust for number of tests. Good. So for those of you who are just tuning in, I've just started recording. The question was to talk a little bit about the metrics that the state is using and why they might be good or bad. And so, Berkshire County, it's about the size of Rhode Island in terms of population. I'm sorry, about 1/8 the size of Rhode Island in terms of population, about 7/8 the size. And the state color metrics is just looking at the number that tests positive per 100,000. And one of the reasons this is so bad is that if you test more and more people, then the number who test positive isn't so bad. Imagine the extreme. You test 100% of the people, and 15 are positive. And the other extreme, you test the sick people, and 15 are positive. And maybe here we tested 8,000 people, and here maybe we tested 100 people. If you look at the rate per 100,000, this is going to be disastrous. If you look at the rate per 100,000 over here, oops. That's going to be extremely mild. But the original metrics by the state were treating these as the same. And so when trying to figure out how to deal with COVID, well, a lot of us, including one of the student groups, were saying that this is not the right metric to use. It's penalizing states for, or counties or towns for doing extra testing. All right, so it sounds like there's an audio issue. What I'm going to do is I'm going to just mute everybody, and then when you talk, just mute. Okay. Can somebody give a thumbs up if you can still see me? Everyone, can you give a thumbs up? Okay. Interestingly, when I mute everybody, it does not mute myself. And so the new metric was to include how much testing. And so there's a lot of different ways to do this. And so one way to do this is to give yourself a credit. For the more people that you test, the less severe it should be, and in some sense, like a rescale factor. So there's a lot of different ways to do a rescale factor. So we can take the rate per 100,000, and then let's multiply by something. What's the maximum test rate we could have is 100%. And what's an average test rate? Let's say 7%. So you get no credit unless you do at least 7%. But maybe what we can do is we can look at 7% divided by percent that you test. So now if you test 100%, it's going to decrease your rate accordingly. The problem with this is that if you test too little, it might actually increase your rate. And you might now be penalized for not testing enough. And so you could say, well, maybe that is fair. Maybe we should have a penalty for not testing. Or what you could do is you could put in a 1 over here and then take the minimum. And so this way, there's no penalty if you're not doing a lot of tests. And you could imagine a situation where nobody seems sick, so that maybe you aren't going to be doing too much testing. One of the real problems is you have to be prepared for small numbers. One of the towns had a 10% test rate 1 week, and it was 1 out of 10. And so the problem is when you have very small numbers, one value can have an incredibly large swing. So whenever you're looking at the data that you're asked to analyze on the exam, You always ask, is this reasonable? Is this a good statistic? Any other questions on this? Any other topics people want discussed?
I have a question about grading the class in general. So I know we've had some grades so far in terms of homework, and I'm not sure if we've got our presentation grades, but what percent of the class grade is the final?
So the final will be 40%. The homework that the grade and I did together, that you did through Glow, is 20%, and then presentation and the other homework that I graded is 40%. And so there's no one who did poorly on the presentation. If people want to know the details on how they're doing, feel free to just shoot me an email. So it is designed to be hopefully as stress-free as possible. So everybody should have a pretty good bulwark going into the final.
Could we review spatial modeling?
I'm sorry?
Did we review spatial modeling?
The ones from the presentation?
Yeah.
Okay, so I'm not going to go into anything in great detail that was covered by a group that presented.
Oh, sorry, the ones from the very beginning.
Which model? I'm having trouble hearing you.
Sorry, it was the ones from the very beginning, the lecture 8 on September 30th.
Let me see. Okay, so let me just start the share. Trying to see what this was. Okay. So this is this is an advanced presentation where a lot of the material is coming from a recent paper on the subject, and I think it's great to see some stuff like this. The main point to get away from something like that is we have, let's say, a bunch of towns, and I'm going to just draw the centers of the towns, and we want to try to take into account somewhat how they are interrelated. One of the other hats I wear is I am a senator for Phi Beta Kappa, and in fact, in a few minutes, I have to roll off to a meeting there. And they had their National Book Awards last night. And one of the books that won was a very interesting story about the effect of the automobile on Fourth Amendment rights and interactions between people and police. And one of the interesting quotes was that as the cars came into play, all of a sudden in 10 years, you had more connections to a city that was 100 miles away than you did 10 years ago to a town that was just 15 miles away. And so in the spatial models here, the question is to try to take into account how we should weight the different interactions of the regions. And so for instance, let's say you have a city here, Boston, that is going through a COVID epidemic right now. The places that are very close to Boston, there might be a lot of interactions with them, and maybe they should be given some hit for being near Boston. But maybe the towns that are further away are such that the interactions with Boston are weak enough that we don't really want to have too much of an impact in something like this. And so in terms of trying to come up with a formula to deal with either the spread of COVID or how much you should weight things, you might weight things based on interaction. And an easy proxy for interaction is distance. Things that you are closer to, you might give a larger weight. So for instance, one possibility is I could look at the distances, D1, 2, D3, D4, D5, D6, D7, D8, and D9, and see how far Boston is from everything. And then I want to do some kind of weights. And so the weights have to sum to 1, and they have to be non-negative. So 0 less than equal to each weight is less than equal to 1. The sum of the weights, which is W1 plus Wn, should equal 1. And then the question might be how to assign the weights. So you want the places that are closer to have a larger weight. Any thoughts as to how we might do this? And there's more than one right answer. So one possibility is I could sum all the distances in the denominator. Let's just do the weight for W1, because the other ones should be similar. Anybody want to give me what might be a good weight for W1?
Zero 0.5.
Okay, why 0.5?
If it's supposed to be great or in the middle between 0 and 1, I feel like 0.5 is a good number to choose because it's in the middle.
Okay, but I want to somehow take into account its distance. It's D1.
D1 over D1 plus all the other distances.
So one possibility is to just do D1 over. And now if I sum the weights will sum to 1. The problem is, which one is going to have the greatest weight now?
The one that's furthest away.
You're close or far away?
The one that's furthest away.
The one that's furthest away is going to have the greatest weight. So one thing you could do is you could do maybe D2 plus D3 plus dot 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 plus D9. And so now you basically just throw away D1, and so the one that has the smallest one is going to have the largest weight. What's the problem with this, though?
That won't add to 1.
It won't add to 1, so what's it going to add to? I get that it adds to 8, because when you add all the different numerators together, D2 is in everything but the second, D3 is in everything but the third, D9 is in everything but the ninth, D1 is in everything but the first. So each D occurs in the numerator 8 times. So all I would have to do is just divide the denominator by 8. And now I have some weights, and they will give the most credit to the ones that are closest. Does that work? Or is this off by a little bit? What do you think? So always do some special cases, do some smaller cases to try to get some intuition. Rather than trying to do 9 cities, let's just try to do, say, 2. So imagine we have just D1 and D2. Then we would have D1 over 2 minus 1 d1 plus d2, and d2 over 2 minus 1 d1 plus d2. And yes, they do add up to 1. If we had 3 d1, d2, d3, we would get d1 over 2 d1 plus d2 plus d3. I'm sorry, the first one would be d2 plus d3. The next one would be d1 plus d3 over the same, and then d1 plus d2 over the same. And we can see that, yes, it does add up to 1. Another possibility is you could try to play with inverses. Look at 1 over d1, 1 over d2, dot, 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 1 over d9. And now the smallest one would be the one that would give you the greatest contribution. And so if we do that, we could look at maybe, oops, 1 over d1 plus 1 over d2 plus 1 over d9, and then do 1 over d1. And so now, whichever one is closest is going to have the largest weight. And it's clear now that this is going to sum to 1. And so rather than using the distance, we use 1 over the distance. And so it is going to give greater weight to those that are closer. And the whole idea is to try to get a good model to describe which interactions really matter. When you're trying to look at the spread of COVID, what might matter is which town has the supermarket that everyone goes to. Not every town has a supermarket. Or are there youth sport leagues, and is there travel going on because of that? And so the whole point of the spatial model is to try to get a sense of how can we adjust to take into account the interactions. Which places in the pre-COVID era do you think Williamstown interacted most with? As a student, what did you interact most with? So I see in the chat, something else. So I see like North Adams, Albany, and Pittsfield. So a lot of it is you're traveling to Williamstown. If you're flying, you fly in either Boston, New York, and maybe take Peter Pan or some bus, or fly to Albany, take some shuttle from there. So you're going to have interactions from those places. All of the cities and towns in New York between Albany and Williamstown, I doubt anybody really goes to those at a significant level. All right, I have to run to a meeting now. I left you guys an article to read and a good video to watch. And then we will do, let me check, the math review next week on Monday. So I will send out an email for people to just go through and make sure that if you have questions that you can send them to me in advance so I can try to prepare things. Whenever you want to take the exam, I am happy to email you the exam so you can start. All right, have a great day, all.